Thank you for joining me today. I'm going to be talking to you about equation word problems, how to set them up, and then in some cases solve them if that's what they're asking of us. So let's take a look at this first problem here. To rent a canoe, it costs $5 per hour. What would the total cost be to rent a canoe for 3 hours? Write an equation to represent the situation between the total cost and the number of hours, t, for renting the canoe. So in this case, a couple of key terms here that they're using. Per, okay? Per is a word that they use to denote multiplication. So that means we're going to be using some type of multiplication here. Another key term that they use here is total cost. Total cost is always going to be what we consider to be a dependent variable, okay? And then hours. Hours is always going to be your independent variable. So the way you set these equations up is always in relation to the total cost. So total cost is going to be equal to, because again, we want to know how much it's going to cost. That's one of the first things we probably think about before we go on a trip. How much will it cost me? So the total cost is going to be equal to how long you're going to be going. So your original equation is going to involve time. And because the time is independent, we're going to relate that to how much it costs. So $5 per hour would mean 5 times however many hours we choose to do the canoe. So they actually give us a value here of 3 hours that we can actually substitute in. So we're going to take our total cost, set it equal to 5 times t, which is 3, the time we're going to actually spend with the canoe. And that ends up giving us our total cost of $15. All right. Most of the problems that you get will be set up in that exact way, especially if they're dealing with total cost. Total cost will always be on the left side of your equation, and then the time will always be on the right side, typically with a value, in this case like 5, however much it costs per the time you're going. All right, let's take a look at a different type of problem here. The next one says, John earns $25 per week to babysit his little sister. How many weeks will it take before he has earned $375? They want us to write an equation to represent the situation. Now in this case, they give us a couple of variables, E and R, to represent weekly rate and earnings. Well, in this case, they've already given us E, $375. Okay, so that's what's going to be set equal to our other rate. And again, you can see that there's a consistency here with some of the terminology they're using. The word per, again, is representing multiplication. And in this case, he's making $25 per week. So $25 times R is going to give us $375. And they want to know how long it's going to take. So in this case, to solve the problem, you would have to use division. 25 times R is actually multiplication. So we're going to divide 25 to both sides. And we see then, once we do the division, we will get our value, or how long it takes. So in this case, 25 into 375. 25 goes into 37 once. We subtract there and we get 7 minus 5 is 2, 3 minus 2 is 1, and we can bring down our 5. All right, 25 goes into 125. If you're not sure about that, you may have to do some multiplication, but it does go in 5 times. So 5 times 25 is 125. No remainder. So 15, all right? And that's going to be how long it takes him, 15 weeks, in order to earn $375. All right. And the last one here, this one is really just asking us to set up the situation. They're not giving us their actual ages. So as we read the problem, it says Carl is 2 years older than Melissa. It says use an equation to show the relationship between Carl's age C and Melissa's age M. Use a table to show the relationship and then graph. Well, in this case, you can see Carl is 2 years older than Melissa. So that means that C, being Carl, is going to be equal to Melissa's age plus 2. Okay, so if we're doing this in relation to Carl's age C, that's going to be the setup in this case. You can also set it up as Melissa is always going to be set equal to Carl's age minus 2. So depending, you can do this either way. As far as setting up your table, you can set that up as M on one side and C on the other. And because we know that Melissa is always 2 years younger, we can start, or Carl is always 2 years older, we can start with her age. When Melissa was 0, Carl had to be 2. When Melissa was 1, Carl had to be 3. And then you can just fill in a couple more because you'll start to see that there's a pattern here. 2, 3, and 4. All right, and we're going to use that pattern then to create our graph. So let me make a little room for that. And when you sketch a graph, you really just need an x and a y axis. And since this is actually just a real life situation, that's where we really just need to use quadrant 1 of our graph. And this is our, we'll just make M will be down here, and we'll make Carl right here. So Melissa is going to be along our x-axis and Carl is going to be along our y. And ultimately, we're just going to be plotting points, okay? These are actual ordered pairs that we can simply plot, and you'll see a relationship. Could you switch the 2 letters? Yes, you could in this case, because there's really not one that's dependent on the other. But we're just trying to show the relationship and that the relationship is linear. So I'm going to go ahead and plot the point 0, 2, which would mean I don't have to move along the x-axis for Melissa's age. I would just move up to 2, which would be right there. All right, let me mark that. There we go. All right, then for the next one, we can go ahead and do 1, 3. So that's going to be right 1 and then up 3. And that will put us right here. So right 1, up 3. And then the last one, 2, 4. That means to go right 2 and up 4, which would put us right here. And you can see ultimately what we're trying to show you here is within this problem there's a linear relationship between what Melissa's age is and what Carl's age is. You can see that these are going to progress in the same linear manner, and all that allows you to do then is determine a relationship between their ages, which you can already see in the table. So in other words, you would then be able to predict how old one is going to be when one is a particular age. So when Melissa is, let's say, 20, that means Carl will eventually be, of course, 22. This has been a quick tutorial on equation word problems. Thank you for joining me.